This section will be talking about the properties of exponents. In this section, we'll go over some basic rules. The first one is the product rule. And remember, an exponent is just really repeat multiplication. So if I take x to the 5th power, that's just writing down 5 x's and then multiplying those 5 x's together, calling it x to the 5th. So for product rule here, when we multiply like bases, in other words, those a's are the bases, you end up adding the exponents together. So if I have x to the 5th times x to the 3, I'm adding those exponents and calling it x to the 8th. For quotient rule, it's going to be subtraction of the powers. So a to the m divided by a to the n is a to the m minus n. Subtract the powers. For the two different power rules that we have here, notice we have parentheses. So when I take a to the m and raise it to the nth power, you can kind of think of it, it's not really, but a little bit of a distributive property going on here. You raise the m to the nth power, you multiply, just like you would with distributive property to get rid of parentheses, you multiply those powers together. So x to the 3rd to the 4th, you're multiplying 3 times 4 together and coming up the 12th. Anything inside the parentheses will be raised to that outside power. So for this problem, our 4 should be inside parentheses here. So this is going to be 4x cubed raised to the 2 power. There's a little typo there. So I'm going to raise the 4 to the 2 and the x cubed to the 2 power and come up with 16x to the 6th. For a negative exponent, that's going to be a little bit different. They call it a flip and change the sign. It's taking the reciprocal of your base. So if my base is a, the reciprocal is 1 over a, and then you raise it to the positive m exponent. So you flip it and change the sign to a positive. Flip the base, change the exponent sign to a positive. So x to the negative 3 becomes 1 over x cubed. If the negative is in the denominator, you've got 1 over a as your base. You're going to flip that and make it a to the positive m. So 1 over x to the negative 5 becomes x to the 5th when you flip it. Think about it this way. When you cross this line, this division bar line, you change the sign of the exponent. So it's now x to the 5th and it's up above the line. Here, x to the negative 3 was above our division bar line. So when I cross the line with it, it becomes 1 over and then x to the positive 3. So when you cross that line, you change the sign of the exponent. Anything to the 0 power is automatically 1. So in this case, it doesn't matter what's inside of here. When you raise it to the 0 power, the answer is going to be 1. There's a few warnings down here towards the bottom of the page. If the bases aren't the same, you cannot simplify any further. And a few common errors, a negative a to the n is not the same as negative a to the n. Let me give you a for example on that. If I have negative 2 squared, I take negative and then the base is just the number 2. So my answer comes up negative 4. You can test this out with your calculator. Type it in exactly that way, it'll come up negative 4. However, if I put the negative 2 inside parentheses, now my base is negative 2, and that's what I write down twice. And a negative times negative will come up positive 4. So you've got to watch, whether it's inside parentheses or not. If the bases are different, again, you can't do anything with the exponents. And if there's addition between two bases, you can't do anything with the exponents. It's only if you multiply like bases that you add the exponents.